Okay, hello, what's up? Word crashed for me, so I'm doing it again. Alright, here we go. What is the length of A? So for this, it's a right angle triangle. We've got to use Sohcahtoa. This is hilarious, by the way, the typo. So let's look at the 63 degrees. So opposite and hypotenuse. So OH is sine. So I would just write, I don't know if I need to do that. Hang on. Let's see if it works. Sorry, degrees. No? Okay, hang on. Let me get rid of that. Whatever. Anyway, sine 63, sorry, equals A over 14. And I need to make A the subject. So I need to get rid of the 14 times. So 14 sine, okay, that's good, 63 degrees. Okay, so B is correct. The location of three towns is shown opposite. What? Okay, so this is meant to be vertical. The bearing of B from A. I'm guessing we need to know, oh yeah, we need to know this angle. This is the answer. Because this is north, the bearing goes like this, clockwise. So we just need to know this angle. So these three angles add to 180. So all we need to do is 180, take away 73, take away 43. Or you can add these two and take it away. Doesn't matter what order. Okay, so 107, take away 43, 64, I think. Okay, let me double check. I like double checking. 116 to be confident. That looks right. Next one. Wait. Oh, wait, what? Hang on. What do you mean? Why is my answer not there? What did I do wrong? Is this, maybe this was a mistake. If you add those, that's 116. That leaves 64. This has got to be 64, right? Oh, B from town A. I'm an idiot. I'm doing B from town C. Alright. There we go. So I'm an idiot. That's 64, but whatever. We need this B from town A. So imagine there's a vertical line here. We're looking at this angle. So we need 180, take away 73. Okay, sorry. I made a mistake. But at least I noticed it. That'd be embarrassing. What if 64 was an option? Then I'd be done for. Okay, 107. This one, C. Alright, next one. Okay, sine rule, cosine rule, what are we talking? There's no right angle triangle. Looks like the sine rule. Okay, so x is opposite this. We don't know this angle, so let's figure it out. 39, 29 makes 68. So, okay, 180 take away 68 is 112 degrees. And then what? Okay, so 112 goes with the x. So in fact, let's do it. My formula. So I don't know, why am I calling it your formula? What do you mean? You didn't invent it. X over sine 112 equals, okay, another side. Why does that say 29 degrees? Again, I think it's a typo. We don't know that length, so we have to go with 5 over sine 29. Okay, good. Oops, I don't know what I just did. Okay. And then I need to get rid of the sine 112. Sorry. Good, that's better. So I need to move it over here, multiply by it. So x equals 5. Sine 112. The reason I keep writing degrees is because otherwise I think you can sometimes forget the difference between an angle and a side. Hang on, let's try to... Are you kidding me? You can't just delete the brackets? This is all part of one thing. Oh boy. I don't get it sometimes. Whatever. Okay. So there we go. Which one is it? This one, I think. Oh no, sine 29. This one. Okay. Let's move on. How would sine theta be calculated? So sine theta over 5. Okay, so it's still the sine rule. Remember, we always match opposites. I don't know if I'm explaining it enough, but it's good practice. Sine theta over 5 has to equal sine 64 degrees over 8. Okay, opposites. Now we need to get rid of the 5, so we multiply by 5 and it ends up over here. So sine theta is 5 sine 64 over 8. Good, did it the right way. 5 sine 64 over 8. Yep, so that one. Okay, moving on. What's the area? So the formula for area, half base times height, but it's not. We don't know that, so area is half AB sine C. Okay, something like that. So half times. So what is important is that the A and B are next to the angle. So it's got to be these two. 32 times 18 times sine of 40 degrees. Now I made a little shortcut here. See, I've made these quick formulas, so I should be able to just do 0.5 times 32 times 18 times sine 40. Okay, 185.12. Cool. So B. Alright, and it's meters squared because it's measuring the area. Just notice whenever you're measuring area, you know, it's a two-dimensional thing. We had two dimensions that we used, 32 and 18. The sine 40 is more just because of the shape of it, okay? Okay, what is the length of x? Okay, sine rule again, or actually cosine rule, okay? Because it's this involves all three sides. Even though this one has three sides, we didn't use the 20. Okay, so yep, cosine rule, which is very similar to Pythagoras' theorem. It's actually a generalization, so we're going to do, we'll call it, oh yeah, it is x squared. So 5 squared plus 9 squared minus 2 times 5 times 9 cos 50 degrees. Okay, and then we're going to square root it. So let's try that. 5 squared, why am I putting space, plus 9 squared minus 2 times 5 times 9 times cos 50. Now whatever that is, 48.14, square root it. So math does square root. Okay, so I get 6.94 or so. What? Oh, okay, yeah, no, they are, sometimes they do that. They are checking to see if you round it correctly. So this is the correct answer. Make sure you round correctly because there could be a question like that and then you don't want to get it wrong even though you did the right steps. Okay, alright, let's move on. So what's the value of theta? So it's the largest angle. There's three angles. The one opposite the 7, this one should be the biggest. So just imagine we're finding this angle. That's theta. So yep, we can use the formula cos theta. This time it's a squared plus b squared minus c squared. These are the a and b, okay? So I'll just write it out. I'm just going straight into it. 6 squared plus 5 squared minus 7 squared. So the one that's minus is opposite, and then over 2, hang on, let's just do that. Okay, times 6 times 5. Just these two. Okay, now if you wanted theta at the end, you'd have to do inverse cos, but for now, that's it. Okay, which one? Okay, this one. Doesn't matter the 6 and 5 what order, because they're both plus. The minus is different. So anyway, D is the answer. Alright, let's keep going. I won't do all of these. Let's do the first one. So that's opposite hypotenuse, so it's sine. So sine 56 equals x over 35. We need to times by 35. So x is 35 sine 56. Okay, I'll just quickly do it. Oh my god, this is my life doing trigonometry. Okay, 29.2 decimal places. Okay, 29.02. Okay, these are units, meters. Hooray! Now I know what that length is in that question. Alright, let's do this one. So, okay, tan, because it's opposite and adjacent. So tan, 50, same angle. Geez, they're not very original. 17 over x. Now the x is on the bottom, so be careful. It's different from that one. You need to times by x, but then also divide by 1056. They basically swap places in terms of algebra, okay? And algebra can sometimes feel like a whole bunch of random rules. They actually make perfect sense. That's why earlier years of algebra at school are so important, so you understand it. Okay, 17. Just a bit of a lesson there for you guys. 11.47. Hang on, I'll just put it here. Equals 11.47. What units? Millimeters. Why not? Bit of variety. Finally. Okay, I'll just do B. I don't want to do all of them. Okay, so we've got adjacent, hypotenuse, so cos. So cos theta. Notice I try to be consistent with these. Every time I start with either sine, tan, or cos, or whatever, and just state it. Equals a ratio. And if it's whatever the angle is what goes there. In this case, the angle is theta. Okay. Okay, so that'll be adjacent over 30. So 16 over 34. Sorry, just making it sound confusing. Then to get rid of the cos, the opposite of cos is inverse cos. Okay, hopefully you're getting the hang of that. Okay, cool. I'll do bracket 16 over 34. Cool. So, this one, okay, hang on. Convert it to degrees. Math. Okay, 16 over 34. Okay, I guess 61. What does it want? Nearest minute. Okay, this one doesn't convert. Let me just quickly. So it's going to be 61 degrees. And let me figure out how many minutes. So that number. Just give me 1 second. We're taking home. And 56 degrees. Okay. Okay, so that's what I. Sorry, 61 degrees, 56 minutes. Okay. Double check on your calculator that that should be the answer, because I've rounded it up. Alright, let's just move on. She went on a bearing, so north 43 degrees west. So imagine north is straight up. She's going west side, this way. How far north is she from home? Okay, maybe I'll just do a really quick. Check this out. Look how quick. Look how quick it is. See that? It's already got the P. It's already loading stuff. Look at that. I click, and within seconds I've got paint. Okay, so it is just a really rough. This is so stupid. North, okay, 43 degrees west. So that's about this way. Jeez. Okay. Oh my god. This is so. Oh wait. Oh god. Alright, whatever. That's what I'm trying to express to you. Okay, how far north? So we're looking, I could put a line down here and across, or a line across here, it's the same. I'm going to try this way. It seems I've got more space. This is a right angle. If that's 43, then this will be 43 too, because this is north-south, this is north-south, so it's just alternate angles. So 43 degrees. Alright, how far north? So we're trying to find this height, x. Now we know she traveled 8.5 kilometers. So there's an eraser. Whatever. I should make the eraser a bit bigger. This will do. It's just nice and quick. I want to do, where's my brush? So 8, let's try again, 8 point, try again, 8, try again, it's too small, 8.5 kilometers, alright? I'm sure there's a better program for this, okay? Alright, so now we can actually sort of do it, the same as we do any other trig problem. So we're going to do, so we need to find out its adjacent and hypotenuse, so cos. So cos 43 degrees is x over 8.5. Okay, we need to times by 8.5, so x is 8.5 cos 43 degrees. Okay, let's try it. 8.5 times cos 43. Alright, 6.22. I'll do 2 decimals. Oh, 1 decimal. Okay, fine. Be that way. And it's kilometers. Alright, next bit. How far west? Where's my beautiful picture? This line. So let's maybe do a y. This time it's opposite and hypotenuse, so sine. So sine 43 degrees is y over 8.5. We need to times by 8.5, so y is 8.5 sine 43 degrees. Anytime you notice a pattern and you can take a shortcut, feel free to jump ahead, right? With these things, sometimes it happens, but otherwise I like to just follow the process one step at a time. 5.8, okay, 1 decimal. Okay, so hopefully this makes sense so far. If you travel northwest on this particular bearing for 8.5 kilometers, you end up exactly or close to 6.2 kilometers north and 5.8 kilometers west. Notice they're very close because it's nearly a 45-degree angle. It's just a little bit more north. Okay, what's the next question? Okay, from where she is now, she's over here. We need to put a north line again. So we're trying to find what's this bearing. If she looks back homewards, so we know this bearing was north 43 west, like up this way. But going backwards, we need to know this angle. Now this angle is 43. That's neat enough. These two angles are co-interior. This happens a lot when you've got north here, they're co-interior. So we just need, okay, 180 minus 43, which is 137 degrees. And that's the answer because it's north and then going east, like clockwise. I like putting a T to say that it's true bearings, but anyway. Alright, let's move on. This one's got a diagram, so you guys will be saved from my awful drawing. Cam worked 13 kilometers east and then 12 kilometers south. That's nearly on a 45-degree angle. Okay, the value of theta. It's going to be close to 45, but opposite over adjacent, we're going to use tan. So tan of theta equals 12 over 13. Opposite of tan is inverse tan. So tan to the minus 1 of 12 over 13. Okay, so I can do that. Convert it to degrees at the end. 12 over 13. Cool, so I got, what is it? Yeah, nearest degree, good. 43 degrees. Okay, so just remember, anytime you're finding an angle in trig, you use inverse tan or inverse cos inverse sine. What's his true bearing from his starting point? So he started here, went that way. All we need to do is, there's 90 here, plus that extra 43. So, what the? Oops. So 90 plus 43 is 130. 33 degrees. That's the true bearing that he went on, and his compass bearing. Oh, okay. Remember, compass bearing, we have to start either from north or from south. It'd be nice to start from east and then go down, but we're going to start from south and go this way. So we need to compare 133 to 180. So the difference is 47 degrees. So he's going south, then 47 degrees towards the east. So W and E are right next to each other. Okay, so this true bearing is actually the same as this compass bearing. Okay, and that they both represent southeast on this way. Okay, these ones, I'll just do a couple. These are obtuse angles, so remember they can be negative, and there is a sort of a pattern, but just use your calculator. I can't really do the ones with minutes, but that's easy on your calculator. Let's try this one. 7, 10, 128. Okay, I can tell it's gonna be negative, but we'll see what its value is. So 7 times 10, 128 minus 8 point, now how many 2 decimals? 0.96. Okay, next one, let's try 11 cos 149. Okay, before I click enter, cos 149, I'm just trying to think. 0. Right. Yeah, again it's negative, so let's see what we get. Minus 9.43. Okay. And that's to 2 decimal places. These are 3 significant figures though. 1, 2, 3. But decimal places is just after the decimal. Okay, where we're up to? Just 1 page left. Alright, I might have a break. How much time is that? Okay, I'll leave it there for now. Thanks for watching so far.